to show you the same problem, only using long division. So same idea. If we're given that 2i is a 0, then we know that negative 2i is also a 0. So I'm going to do something a little weird. I'm going to sort of think of these as what they would look like as factors. And so if 2i was a 0, x minus 2i would be a factor. And if negative 2i is a 0, then x plus 2i would be a factor. Now this looks a little weird, but watch what happens. If we multiply this out, we get x squared plus 2ix minus 2ix minus 2i squared. Sorry, 4i squared. The 2ix's cancel out. I squared here is negative 1, so we end up left with x squared plus 4. Just a little side note, just to sort of confirm that this makes sense. If you were given that x squared plus 4 was a 0, or was a factor, sorry, and you were solving that, you would subtract the 4, square root both sides, and you would get plus or minus 2i, and those are the two zeros. So it does actually make sense. That result does in fact make sense. So now that I have x squared plus 4 as one of my, as a factor, I'm going to divide the x cubed minus 3x squared plus 4x minus 12 by x squared plus 4 and see what the remaining factor is. I'm going to change colors to make it easier to see. So x squared times what is x cubed? That's x. X times x squared plus 4 is x cubed, x cubed plus 4x. Notice you could think of there being like a 0x squared there because there's no middle term. We're going to subtract, so we change it to addition, change all the signs, and now when we add, the x cubes cancel out, we get negative 3x squared, and then nothing, and then the minus 12 comes down. And we're going to divide again. X squared times what gives me negative 3x squared? That's negative 3. The negative 3 multiplied by the x squared plus 4, that's negative 3x squared minus 12. And if we subtract those, change to addition, change the sign, and everything cancels out, giving us a remainder of 0, which we expected. And the remaining factor is x minus 3. If x minus 3 is the remaining factor, then the other 0 is 3. I personally prefer the synthetic division method, but this is an option if you like it. That's all for now. Thanks.